It's about to start, we'll talk about code or whatever we'll talk about today. It's about to start, so please hang tight while I check that everything is okay. Sound check, camera check, lights check. How's my hair? Oh, wait, I don't have any hair. Maybe put some pants on and I am good to go. So get ready wherever you are, 'cause this stream is about to start. Get ready wherever you are, 'cause this stream is about to start. Hello everyone and welcome to another meeting of the C++ Digital Signal Processing JUCE study group. And it may seem like I'm alone, but I'm not. Cwits is with me today.
Hello.
Here. Hello, Cwits.
Hi.
So, how about you go first and tell us about the issues you have been having with your code?
So previous time I was I was promised that I will make some external audio output and audio input for my Raspberry Pi, but one of the problem I run in that external audio input, like a ADC converter, needs external clock that Raspberry Pi can't produce. So I have to make some kind of PCB with the external clock supported that supports external clock. I'm not sure.
I see. Interesting. What kind of clock are we talking about? What is the frequency that we are dealing with here?
I'm not sure for now, but it could be around megahertz. I don't know. In the internet there is a 1 second. I can share my screen. In the internet there is some kind of Hi-Fi Berry DEC ADC Pro PCB, which one have, here it is, the two external clocks. Mm-hmm. One is of course for the ADC, but the second one I assuming that is for digital to analog converter, but I'm not sure. And I have to make something like that, I think.
You are planning on doing it yourself or buying this? Is it like a chip that you can buy, or do you have to buy? I guess it's surface mount, so it's probably not something that you would do yourself. It's not a DIY kit. So are you interested in doing it yourself or buying this Hi-Fi Berry?
Of course I can buy it, but more interesting will be to do it like by myself. It will be more interesting and a little bit more complicated than just buy it and to put on the top of my Raspberry Pi.
A wild Fotis appeared. Hello, Fotis.
Oh, hi, Fotis. Seems like we can't hear him.
Yeah, Fotis, we don't hear you, so it seems to be on your side because neither of us are hearing what you have to say. So anyway, so how deep do you want to go into this? Do you want to buy some analog to digital converters and as integrated circuits and then build the rest of the circuit around it? Or do you want to do your own digital analog to digital converter? Because it's something you can go really deep into that.
Hello, Fotis. We can hear you now.
Yeah, sorry. My Elgato microphone doesn't want to work today, so instead I use my laptop's microphone.
Okay.
Anyway, as I was saying, we are finally installing optical fibers in our house.
Yay!
We finally have good internet.
Yo.
And I was helping my dad move some stuff around. So what did I miss?
Cwits is giving his update for now.
Okay.
Not much. Answering to your question, Leandro, I think making ADC chips is way more complicated than make PCB on the top of ready made chips. So I think I will buy already made ones and just made the PCB and solder everything together.
Yeah, another thing I guess you could do that would be perhaps too brutal, but you could, I guess, is you could use the analog pins from the Raspberry Pi to read voltages. So you would probably have to have some kind of circuit to protect the Raspberry Pi from high voltages, but you could use the Raspberry Pi itself because it has an analog to digital converter in the board, right?
Yeah, yes, I assume yes. I doesn't check for that, but I think the resolution of that will be quite low, so
yeah. If it is anything
not
like the Arduinos that I know of, it is 10 bits.
Maybe it depends on chip.
I see.
Because the different microcontrollers have different ADCs built in. For example, STM32 has, I don't remember precisely, but maybe some 16 bits, maybe
hey,
12.
that would be a good start.
Maybe 12. I don't remember.
Okay, so what else have you been up to?
One second. Sam Lou? What? Speaking about making controllers, making chips in a basement of your house, these guys, Sam Zaloof, are making chips in the basement. So it's not so impossible. Like, he has YouTube channel where he can...
Oh, you're talking about literally making ICs?
Yes.
That's impressive. No, I was just thinking about doing it with discrete components, where you would say, find a schematic for an analog to digital converter and build that with discrete components. But yeah, this is much more hardcore than I was thinking about.
Here a guy showing how to do everything, like a full tutorial of different. He has different equipment on the basement of his house. He bought a lot of and started doing his components. So why not?
Impressive. But I guess this is very deep into the rabbit hole.
Yeah, it could be. So he's making some tests. So, yeah. but this is not impossible. So why not? Kind of. But for making these smaller ones, I think I'm too lazy to do this, and this is a little bit.
It's not a matter of
field
laziness. It is an entire new hobby that we are talking about.
Kind of. So yeah, this is one of the topics. No, still I can connect DAC to my Raspberry Pi, but as I said, I'm too lazy. Maybe later, someone I will do that. But maybe not. Maybe I will make the whole PCB and just order it from China or something like that, and then I will try to connect things together.
Do you have experience doing this?
I have little bit experience making PCBs, and it was quite successful, but very little bit. Just a couple PCBs for my home projects and nothing more.
I see. It seems like we are all getting interested in electronics here.
Yeah, but I have a lot of experience in soldering, so to solder everything together will be not a huge problem.
Okay. Well,
Nice.
Unfortunately, I cannot say the same. I haven't burned my fingers, but I'm not too good with the soldering iron. All right.
This is cool experience. So.
Yeah, and in terms of software, did you work on something?
Yeah, I have switched my screen. I have do something further. I have made some kind of loops. So I can make like MIDI pattern, which one is looping through itself, and I can basically play some sounds. Sorry, I cannot demonstrate right now because I don't have external headphones to plug in my Raspberry Pi and show everything. And for now, nothing is working. But so major problem of my code was that everything in terms of looping was working okay, but it was not so precise enough for me. So yeah, I ran again into the same problem I had previously, that I cannot do precise time tracking for my things. So I'm trying to figure out how to do that. So I made simpler version, simpler project where I trying to achieve the precise enough time tracking. And
are you using some new strategy to track time?
For now, no. I was trying. I had this one. What you see here is pretty similar to what I have in my project. Yes, this is one strategy. Also, I have tried to make this on the built-in timers in Linux. Like a set, there is function set timer, and we are defining like time when it fires out, and yeah, but it also not so precise enough, and after some time, it is slowing down in comparison, for example, with my phone metronome. Yes, like after 100 beats or ticks, these built-in Linux timer are getting slower in comparison to the metronome of my phone.
And do you trust your phone?
More than this code.
Okay. And is this something that is even an issue? Because as far as I understand, different pieces of hardware may be running at different clocks, and none of them are wrong. It's just that they are running on different schedules. So do you think that it's sensible to try to compare this to, which is running on the Raspberry Pi or on your computer, compare that to a phone?
I think no, because there is, I assume that there is some kind of compensations, and developers of metronome had thought about that. The speed of processor could be various, and they like where's my English? Took into account that.
I see.
But yeah, this strategy is not good enough. So I had experimenting with my old strategy, where I'm sleeping sometime, and then I'm trying to get some differences between start point and end point. Yes, but the problem is where if I use sleep, then clock become also not precise enough.
Yeah.
For example, I can try to show.
And you also had that hybrid idea that was quite nice, where you would sleep for some time because sleeping is relatively inexpensive, and then you would go into a busy wait situation, so you would have a more precise timing.
Yes, I didn't try this yet, but still. Look, for now, if I have like those pulses per quarter node around 960, I have to sleep. How much it was? Sorry, I don't remember. I like around 520,833 nanoseconds, something like that. Yeah, between those ticks. And if I don't have to, if I'm not sleeping, these values are very close enough. Okay, this is some kind of error here, but other values is not far enough from this value, and this one works fine. But problem is where if I'm not sleeping, this one consumes 100% of CPU usage. Like what we have.
Yeah, I remember that was the trade-off. You would do a busy wait, but of course it's a busy wait, so it takes a lot of CPU.
So I had compared this one without sleeping with my phone metronome, and this seems like 120 BPM, yes, quarter notes. But this one, it's 100% of one CPU, and this is not good enough, I assume, if I want to process real-time audio and MIDI in my program. This will cause some kind of glitches, I think.
Yeah, and even if, well, is this something that you care about, really? Do you care about having other programs running at the same time? I guess not, right? It is a
No, no, no.
multi-process operating system, but you can sort of pretend that you are the only process that matters.
Yeah, yes, of course. My Raspberry will run only this program, only my program, and nothing more. No, for now, I think. Maybe later there will be some kind of different programs running, but I'm not sure. So, but if I'm using some sleep function, these values are getting more high. I'm not sure how to say that. Like in comparison, it's run out. The previous one without sleeping was around 5.2, blah 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 blah. This one is like bigger, yes, and this causes some kind of imperfection, and everything happens slower. So I think this is not good enough also. And today I was thinking about it, and maybe there is some other way to track time in MIDI with with this PPQN and some kind of enough resolution to make everything works together.
Here is something. I don't know if it applies because I have never worked on this area before, but something that you could look into is perhaps interruptions. You would receive a notification, so to speak, when some event happens, and then you wouldn't have to be polling. You would be notified about things. It's the Hollywood principle, right? Don't call us, we'll call you.
Yes, this could be a kind of solution, but how to call these interruptions in the precise timing?
Yeah, that I don't know.
This one solution with a built-in Linux timer doing something similar, yes. I have function with a callback where I'm doing what I want to do, and this function is calling callback from time to time in a certain period of how much I want it. So something similar what you're speaking about right now. But as I said, maybe I'm doing this wrong, and this is the reason why this one is not precise enough. Maybe I don't know. A lot of things that I don't know.
Okay.
And I don't know how to deal with that. So I start to think that maybe there is some other way of doing this, because I was looking for open source DAWs like LMMS, QTractor, Ardor, and I didn't found that they are using, for example, clock nanosleep function for waiting, yes, for not waste the 100% of CPU time and doing things in some kind of different way. Maybe I have to study them a lot more and deeper than I'm doing this right now.
Yeah, we could also ask around, because there are people who perhaps have worked on this before. For instance, Theo and Bo are here on the chat. Hello. And perhaps they know more about this. Perhaps Theo has worked on something related to this before. So Theo and Bo, if you know what strategy one should use to count time precisely without wasting resources, then let us know how you are doing it.
It would be great if they will know that. But yeah, that's I think all for myself.
Okay.
Last week I was doing this one and doing some research and searching of information and examples on the GitHub, on the internet, but For now, I don't have answer for this one.
Well, it is a fun little challenge to think about, so thanks for sharing. And I guess you have already answered what you're going to do for the next meeting. So I guess with that, can we pass the word to Fotis?
Hello. So before I begin with the not so fun challenge I have for you two, I would like to say a few words about this book. I began reading it. It's called Complete C++ by Walter Savage. I think the last name is Walter. The first name, sorry. It's in Greek, but you probably can find the English version. And I skimmed through the first 2 chapters, and it's pretty well written. Obviously, I'm not a C++ expert yet, so I can't comment on how accurate it is, but it is very well structured. And the first chapter is about the basic elements of C++, and the second chapter is about control flow, or however it's called in English, right?
Yeah, it is control flow. Things
control
like
flow, okay.
if statements, for statements, that
if
kind of
and
thing.
else, yeah, exactly, yeah. And you're creating logic gates like AND or etc. And I really like how the book is very well organized, very cleanly written, and it's fitting because C++ is an object-oriented language, so I could call this an object-oriented book. It's very well made, and it does have a few bits of humor little here and there. For example, there is a class about dragons and another about dwarves, or an example. Or there is a very deep reference, okay, not that deep, a reference to Douglas Adams' The Hitchhiker's Guide to the Galaxy.
That's an obvious one.
Yeah, it has a joke that says, an exercise that says, create a program in C++ that types the phrase, the answer to everything is 42. So yeah.
Is this a book written in Greek and translated to English, or vice versa?
Vice versa.
Okay.
Because Walter Savage is not Greek. But the translator is a professor himself. He does teach C++, and he even puts his own annotations here and there. He does explain a few things further.
When you're writing in C++, can you use Greek characters for variable names?
I don't think you can, but that's not really important, at least for now. Maybe if you would be able to create some sort of field that allows any kind of character to be inserted, like Unicode or UTF-8, because that's where Greek is inside.
Yeah, but I was thinking of writing your program using Greek characters, because it can be fun and it can be useful, especially when you're doing mathematics, which we tend to do in digital signal processing, and mathematicians end up using the Greek alphabet. So that could be interesting.
Yeah,
and I know of very few languages that allow for arbitrary characters in variable names, for instance.
Yeah, but if it were possible, I think that the book would have a chapter on that already. Maybe it does. I haven't read the whole thing.
And do you think that this is a book targeted at beginners and people who may not even know other programming languages, or is it more for people who are already programmers and just want to pick up C++?
I think it's a bit of the latter, because I can actually demonstrate it right now. In the very first pages of the book, there is an example code. Oh, sorry, let me find it. Yeah. So this is the very first program. Can you see it?
Yeah, I cannot make sense of it because it's
okay.
a bit small.
It
but
does have Greek characters in the text that you print. And the text says, Hello, reader. Welcome to C++. How many programming languages have you used? Read the prologue. Maybe you need a book for beginners by the same author. So you've got your answer right there in code form.
Interesting.
You can't get any geekier than that. So I'm gonna need your guys' help in JUCE. I have a challenge. So I thought I would. Somebody made a fork of the Airwindows plugins in JUCE, and I thought I would load the project in Producer, and I'm going to share my screen right now.
Okay. While you're taking care of that, Tail has some info here on the chat. So Tail says, for what it's worth, on an embedded device, I would probably use a hardware timer and interrupt handler. This is what a typical MIDI controller or AG's synth firmware would also do for LFOs, envelopes, MIDI, etc. So that's Tail's input on the question that Cwits is facing. And yeah, it is relying on the hardware timer, that makes sense, and using interrupts. So it is the Hollywood principle. And Tail also says that he thinks you can actually use UTF-8 in C and C++ variable names. Not sure about the first character, because the first character is special in variable names in C, right? You cannot have like numbers as the first character of a variable name, but numbers can appear as subsequent characters in a variable name. So perhaps you can start with a character that is allowed, which is a letter or an underscore, and then use Greek letters. So that could be fun. Anyway, tell us about your issues with JUCE.
Yeah, so this is a project called Bugs and All. It's a fork of an Airwindows plugin that is an equalizer. I think that the standalone was built. Let me show it to you. I can't play any audio through it. Sorry. So this is what I want to build as a VST3, and I can. It's echoing my voice. Sorry.
Well, I don't think that we hear that. I didn't hear any echoes.
I did. It was looping back to me anyway. So it's pretty straightforward plugin. You only have a bass, boost or attenuation, a treble, and the output. That's what it is. And I want to build it as a VST3. And once I do that, I want to tell you what I want to do with the code specifically.
Okay.
But first, I want to get those issues out of the way, because I had to move JUCE to a new folder. Then I had to update to 7.0.1. And it does come with its own VST3 SDK, but I don't know if it's the right thing to do. If not, I can just replace it with the one from Steinberg. But I forgot where to place it. Do you place it here in the audio processors or in the plugin client?
I don't think I did that. I think that the producer thing just downloaded the SDK for me. Or if it's perhaps it's even in the download to begin with. When you install JUCE?
That's what I said. It does come with its own VST3 SDK. It's just that it's smaller in folder size than the one that Steinberg provides. That's it. Where is it? VST3. There it is. So this is only 1 megabyte. Wait. I'm starting to remember now. Yeah, I think I have to unpack everything in here from this part. Yeah, this is the thing that I have to override.
Hang on, why do you have to change the things that are provided by JUCE? I didn't get that.
Because this is barely 1 megabyte, and this is
But what's
It
missing.
is worrying
Perhaps
that,
they are
something is
distributing the
missing.
SDK without the examples, without
Okay.
extra stuff that you don't need anyway.
All right. Let's skip this and let's go straight to producer. So my paths
And Cwits
are.
had something to say. Can you repeat, please?
Oh, I didn't-
I said that Fotis worrying that something missing.
oh,
In no.
your voice is breaking.
Maybe I have bad internet connection.
Oh, anyway. Yeah, I can hear you now.
But do you think that there is something missing? Have you run into any issues when trying to compile or run something and then you decided to look into this? Or did you just see that it was a different size and decided to do something about it?
I think I ran into some problems with the previous JUCE installation. Now I'm just trying to see what's going on because the VST3 is not even appearing here. Shouldn't it have a... It just says up. Shouldn't it have a solution called underscore VST3? Am I missing something here?
I don't know.
Let's see everything from the beginning. Sorry about this, but I had to redo everything from scratch, and I actually rewatched our previous meeting when we did exactly this, and it's still different. So this is okay, right?
Yeah, if I remember correctly, the thing that we built last time was a graphical user interface standalone thing.
Yeah.
And it seems to still be that. If you go to the little settings button that you clicked a moment ago, can you go there again? Yeah, then it says there, probably if you scroll down some more, project type GUI application, you probably want to change that into audio plugin.
Okay, so oh, there you go.
And then it becomes VST3 becomes an option.
I feel dumb. Anyway, I'm going to turn off Visual Studio and reload it.
There was something there that was interesting. The button to build an audio unit was enabled by default, and it surprises me that it's even available. Is audio unit on Windows even a thing?
No.
Thought as
Not
much.
as far as I know. Maybe they did it because they want us to make cross-platform plugins. I don't know. This is the latest version of JUCE.
Yeah, perhaps the plugin formats are independent of the exporters. So you would enable audio unit for when you're exporting into Xcode, and then when you're exporting into Visual Studio, it doesn't do anything.
Or in a perfect world, these would all disappear and it would have just one box that would say clap. And that's it.
You are really excited about clap, aren't you?
Yeah.
And the funny thing is that in our private conversations, you said that you dislike some samplers. You may not want to say the name of them, so I'm not going to say the name of them, but you dislike some samplers because they are formats that are just yet another standard. But when it comes to the plugin format, you seem to like the new standard. So what's up with that?
Yeah, that's a great question. I'm going to explain this. So the problem with plugins is that those compatibility issues, they plague each and every one of the users. But with sample formats, you can create like a plugin that is cross-platform. And so it's a level 2 incompatibility, if you get what I mean. So let's say that plugins are level 1, and once you get that, your sample library standards is a level 2 incompatibility. I'm saying it as simply as I can. So the problem with creating multiple sample libraries is that each one has its own pros and cons. And
as always,
there are some things that you can do in one library that you can do in another. There are some opcodes and stuff like that. But apart from SFZ, there hasn't been another universal, let's say, plugin because all of those, sample library format, because all of those other formats are proprietary and owned by companies. SFZ is one of the best things to have happened because they are open source and you can edit them with the text editor, and you can do the same thing with that other plugin format I mentioned. But the problem with that other sample library format I mentioned is that it essentially didn't need to exist because it doesn't offer anything new to the table. Really, the only easy thing that it provides is that the syntax is in XML, which is a great thing, and I'm glad that people find it easy to create libraries for it. But it doesn't offer anything that SFZ didn't already offer, because this is the problem. We have too many sample library formats and too little sample libraries, too few sample libraries. So instead of creating new formats, we need more sounds. That's my point.
I see. All right. Okay.
And
So coming back to the JUCE issue, now that it is set as a plugin and not as an app.
I do plan to create a video about this, and it's going to be a long rant. So let's not waste any more time with this and go to Visual Studio. Because I have a lot to say about samples, as you can see.
And while Visual Studio is opening, it tail tested, and you can use Greek characters in variable names. You can use, for instance, pi as a character for a variable name, which is really handy, because then your code starts to look like what you see on papers.
Mm-hmm. Oh, there you go. There's the BSD3. Okay, so I guess we go to... do I pick something? Oh, do I have to wait for it to load? No, I think it's loaded. No? Sorry. So do I just click build, or is there anything else?
Yeah, let's try.
Yeah.
I start thinking that I have to use JUCE instead of building everything from scratch.
Oh.
But it's not so funny enough.
By the way, Cwits, I didn't tell you previously because I didn't want to interrupt you, because you did this an analysis of the electronics. But what you did reminded me of my student days when I used to do experiments with RCA cables. I used to plug audio and video devices and see what does what.
Yeah.
And I remember that I had to use an S-video cable once. Remember those that had some very small pins, like 6 pins inside the plug?
But by the way, video and audio, like analog video and analog audio, is something very similar, and you can use audio filters on the analog video, for example.
Yep.
And
the analog filters are, sorry?
This is very interesting thing.
Yeah. And you know that the analog plugins and effects are all the rage nowadays with the lo-fi hip-hop beats to study to. Everybody wants to make their own tape plugin. We were discussing this with Bo on the previous live stream. This thing is building. And anyway, so as I was saying, I was doing an experiment with S-Video when sometime after all the plugging and unplugging, I realized that one of the cables wouldn't go inside the male wouldn't go inside the female one. Oh my God. It doesn't find the SDK. Maybe that was the reason why I used the SDK folder. Should I try it?
If you want to, but I don't really see how you're making the connection. Why do you think that the SDK is the issue?
I think that the issue is that Visual Studio can't find the entry point of the program.
Oh.
Like a DLL main startup is...
You're right.
Yeah, so I guess that would be because we had a project that was a GUI standalone app, and now we have a project that is a plugin, but the boilerplate code generated by producer didn't change. When you generate the project the first time, it creates the boilerplate code, and then it doesn't recreate it. It just changes some internal settings and reopens the project in Visual Studio. So perhaps what you could do is create a new project that is a plugin from scratch, and then copy over the code that you have for the filters. That has a better chance of working, because you are going to start off with something that compiles and loads into a DAW.
So I take all the code from this thing.
Yeah, you would not perhaps take all of the code, but you would look at like the process block code, see how this is an application. It's not a plugin. That needs to change. So I don't know if you would copy and paste the code from this file into the new project, or if you would just look at the two side by side, find the differences, and then adapt. Perhaps that's something you can do. You can just see, oh, instead of inheriting from this class, I should be inheriting from that class. And like that, you go through the files and you find all the differences, and you adapt this to become a plugin. And you would do that by looking at the boilerplate generated for a new project that is a plugin. Does that make sense to you?
It does, yeah. I'm just thinking that maybe there is an easier way to transfer all the inklets. No, it's not. Why?
No, maybe there is. It sounds like it doesn't.
Oh. I guess I'm still new to the programming world. But yeah, I could create a new plugin, a new project from here, plugin basic, and wait. So yeah, I get these.
I see that the name of your directory or the name of your storage is backup something something. Are you working on your backup folder?
Yeah, I'm working on my backup external drive actually, because I'm running out of space in my SSDs.
I see.
So let's create a new project and let's call it Baxandal 2. So while this is doing that, there it is. And here is, it's called new project. So I had to rename it. I can do it.
Well, you can, but again, it generated code using new project as a name. So the name of the class, for instance, is new project. No big deal. It is just something to be aware of.
Yeah.
And that's something that I think is a deeper thing. Remember how when we were comparing JUCE with iPlug2, I said that one of the things I liked about iPlug2 is that it had less boilerplate? That's why. Because sometimes you want to change something about something, and then all the boilerplate is already generated, and then it can be difficult to find what you should be doing instead, and you have to create a new empty project and compare stuff. It is possible, but it's just annoying. And in iPlug2, I don't know how you would change from standalone into plugin and back, but I bet that it has little to do with generating boilerplate.
Yeah, I didn't try creating I think I did. I don't remember if I tried to create standalone with iPlug, but I think it was just easy as picking the app from here and then pressing build. I think it was simple as that, I think. So let's go here. I forgot again. We go to modules, and this should be good. Wait, where is the VST3? No, this is the format.
I think that the VST3 stuff is in the basics.
I found it.
Oh, okay.
So I do this, right?
No, you don't want to be a host,
Okay.
right? A host would be something that loads VST,
Okay, so
and you want to
oh,
be a VST.
yeah, I can disable this. And can I use this? It's not a MIDI effect, it's an audio effect. Where is it? Doesn't I don't pick anything, right? It's just
If it is an
effect.
audio effect, I don't think you have to check anything there.
Okay. FX, there it is. Yeah. AAX, why is it checked? I don't know. So do I press OK on the IDE?
Yeah, in producer first, and that will open the IDE,
Yeah.
and then you try to build that.
So until it builds, I can show you in Reaper what I want to do with it, with the actual plugin. And I think that there is also a JSFX port of the plugin, but I didn't want to do it to that. I wanted to do it with the JUCE because I would like to learn JSFX. I really like it, but unfortunately, I think I will have to learn C++ in order to create a sampler. In fact, I found a great other tutorial series by the audio programmer called How to Create a Sampler in JUCE. And it's a very simple. All you do is the end result is to create a little window with a button that says load, and you load the sample and you play it. And he calls it the hello world of samplers. But I think it's good. Anyway, so here is the shared code. There it is, the source, plugin editor, and now we just copy and paste whatever we find, right?
Yeah, you have to be careful about the copy and pasting. You want to copy and paste the body of some functions.
Yeah.
But you may not want to copy
Maybe
and paste
not everything.
everything everywhere.
Yeah. So this is the main component. .cpp.
And it seems like the component is both doing audio processing as well as the user interface.
Yeah, that's
okay. When you're doing a plugin, those will be two separate things: a processor and an editor.
Yeah, the processor and the editor, I can see them here.
Yeah, so that's why you have to be selective, because you want to make sure you are copying and pasting the right parts into the right classes.
Yeah, but there is also a file called processor. So what's going on here? So maybe this is the audio part and this is the
okay then.
GUI.
So the component is the user interface, and then the processor is the processor. Okay, so component turns into editor, processor becomes processor.
Probably.
So let's take this. And we're going to edit them. Oh, wait. Oh, this is the editor.
Maybe you had to try to compile it without any code.
Oh, okay. Let's compile it. Okay. Yeah, you're right. Let's build it. Oh, I chose the bug. That's not going to be an issue, right? With the bug.
No, it's not really.
Okay.
It shouldn't, at least.
Okay. And it should build in here. This is the reason why I moved JUCE to the other external drive, because every project is like eating up at least 1 GB of data, and it's maddening. And anyway, as it's doing its thing, let's load Reaper, and I'm going to show you what I want to do.
1 GB.
Yeah, it's doing this Visual Studio, and it's look, this is 0.5 GB, and it's already doing all these things. So the plugin processor is a file, That's interesting. And
This is
the
crazy.
the exe file, the executable, is going to appear here once the build is done. It's still building, so I'm loading Reaper. It's going a bit slow because I'm compiling at the same time. Never mind this.
Why you don't have license on Reaper?
It's a long story. I promise I will have it by the end of the year. I promise.
Okay.
There is a meme that shows a picture of Jesus Christ, and it's below his face it says, "You're all required to buy a Reaper license." Anyway, so yeah, thanks Jesus. Oh no, there is not a JSFX of Baxandol. I thought I had one. Anyway, so this is the plugin, right? And I'm going to load the Bertom EQ curve analyzer. And one thing that I love, that I absolutely love about Reaper is the FX chains. And I have created this thing, and boom, it loads 2 instances of EQ curve analyzer. I can just drop the plugin between them. And there
To
you
be
go.
fair,
So,
almost every DAW has that concept. I think that I
Yeah.
would say every DAW has that concept.
yeah, but in Ableton it's a bit cumbersome. It does work, but sometimes the plugins appear minimized, or it's a bit weird.
I see.
Anyway, so as you can see here, even when the faders are untouched, you can see that Baxandol is doing something to the audio. That's the way it's designed, because Baxandol is designed to loosely imitate an actual hardware EQ of the same name. But what I want to do is to make it, so if I'm going to do this thing so you can see how it works. So pretty straightforward. You treble and bass and the output. Anyway, so what I want to do is essentially create a clean version of this plugin. So when you load it, it doesn't do any processing at all. It's completely flat, and it only does things when you move the sliders. So I guess it would be a nice exercise for me to learn how their code works.
Like
Because I wanted to begin with
three-band
a real
EQ?
world example. Sorry?
Like a 3-band EQ.
Yeah, exactly, like a 3-band EQ. A 2-band, right? It's just treble and bass.
Sorry. You can add some mids there. Why not?
Okay,
I
so
could
your
do it.
intent is to detect that all the sliders are at 0, and then you would go into a special case where you just bypass instead of running through the filters.
Yeah.
Okay. Yeah, that
Instead
sounds
of
like a
doing
good
it.
exercise. It sounds like something that
Yeah.
you should be able to do relatively straightforwardly. First, of course, you have to find a way to compile everything, but then that is supposed to be relatively straightforward.
Everything compiled.
I think it worked. Let's see. Oh, there's the VST3. Oh, there it is, the new
Yay.
project. So let me turn off Reaper. And let's just load this thing so we can confirm that it works. I promise I'm not gonna scream this time. That was a meme. I know how to make a meme out of myself. I've been doing it for a decade. So let's wait for Reaper to load again. Oh, okay. So let's go to new. Oh, where is it? Oh, it did take the name of the project. And hello world.
Hello.
So yeah, internal screaming. It works. So now I have to study the code in here and see what I should overwrite and what I should leave alone, right?
Yeah. I guess my suggestion is, on your own time, put both files side by side and start reading them. Perhaps try to order the functions in the same order if they are in different orders. And then you will see how things work. And just by this cutting and pasting job, you'll be in touch with the code. So you'll be looking at the places. Oh, this is where I want to put my conditional. This is the place where I need to detect that these louders are all zeros and that sort of thing. So
yeah, that's a nice point that you're making, because that's exactly how I figured out how to use modular synthesizers, because for a long time those things were scaring me, all those modules and cables and whatnot. So what I did instead was load the pre-made modules and moving stuff around, moving cables or left and right, and see what does what. So it's going to be the same thing. Like I'm going to treat blocks of code exactly like I would treat modules, right?
yeah.
Because the wrong module in the wrong cable can break the whole thing apart, just like with code.
Yeah, and the whole concept of modular synthesis is, in some ways, it transfers to object-oriented programming in the way that you would like to encapsulate some things and expose an interface and hide your inner workings. So the whole philosophy kind of transfers in a nice way.
Yeah, I hope so too. And also that other thing I showed in the previous meeting with the drum plugin with the surround things. Those formats that I discussed, like Dolby Atmos and the ill-fated rival Aura 3D, those are actually called object-based audio. They are literally using 3D objects that are representing the audio, and they are moving it across a 3D space, and the software is decoding that into the speakers realm. So it's always the same concept, just objects and their relationship with each other. So yeah, I'm starting to get the hang of this.
Nice. All right, so
I can turn off share screen.
yeah, it seems like you also have some good homework to do, and
Yeah.
you know what you want to do. All right. So with that, I guess it is my turn. So I have two things that I want to share with you all. The first is I made some progress on my Automixer, the C++ version. And the second is related to the hardware stuff that I'm doing, electronics really. And I know it's kind of off topic because we are a C++ digital signal processing study group, and this is not digital and it's not C++. But there are people who want to do modeling of analog gears, so perhaps that transfers. And in many ways, digital signal processing is related to signal processing in the analog domain. For instance, filters are often designed as digital versions of analog filters. So I think that it is kind of off topic, but not really. So until people tell me that really we are not interested in the electronic stuff, I'll keep talking about it. But first, the Automixer.
I think you're right, because do you know the company Harrison? They make Mixbus.
Yeah.
So these guys, they started by making hardware, and then they moved on to the software world. But to create their own plugins, like their compressor, they actually built a hardware compressor. Then they studied it, and then they created a plugin out of that. So
that's fascinating.
Those two things are mutually exclusive.
All right, I didn't know that.
Yeah.
Very interesting. And to some extent, this is what people do. Like when we were talking to Jading about how he modeled in C++ the Clone Centaur pedal, one of the things he did was run audio through a simulation and then use some neural networks to approximate that. But he could have run the thing through actual hardware. So even if you are in the software world, it pays off to understand a bit of the hardware stuff. Anyway, let's start with the Automixer stuff. And the progress that I made is, well, first of all, for people who have been following my other streams that are not related to the C++ study group, you will know that that whole strategy I had of sending audio from sender plugins into a receiver plugin, which is something that we talked about in previous meetings a whole lot, that whole strategy seems hard to pull off because things get out of sync. Different channels get out of sync when you start playing back, when you start bypassing and unbypassing plugins. And even if the plugin is not doing anything fancy, you are not bypassing, you are not turning things off, you're not automating anything, things could go out of sync in weird ways. For instance, one thing I was doing was kind of giving me latency, but it was negative latency. The plugin was somehow looking into the future. I don't know, that was a weird bug. Anyway, that strategy seems to be hard. So I came up with a different strategy that I'm calling the distributed strategy for auto-mixing. The point is that I'm going to have multiple instances of the plugin, one on each track, but the instances will communicate between themselves instead of sending audio to a central receiver plugin. All the instances will talk among themselves to decide what gain should be allocated for each track. And I will still be relying on the DAW native summing. So I will be doing the attenuations on the different plugin instances, but the summing, the mixing itself, will still be done by the DAW, so everything will be in sync. But the progress that I made in the C++ land is I'm going to follow the strategy that I am going to follow for the JS Effects version, right? I still plan on having both the JS Effects and the C++ versions of the plugins, and I want them to be, to the extent that it makes sense, exactly the same. Same user interface, same way to set up, and same slider, same everything. So the strategy that I'm going to follow is going to be the same. And hang on. Oh, okay. But there is something in JS Effects that is that global channel, that global bus that plugins can talk to one another. And that's called the GMEM, the global memory in JS Effects. And we will need something equivalent to that in C++, and that's what I wanted to study. And this is what I can share with you. So I built this super simple user interface here, and what it does is it has this global counter going on. Of course, this is just one variable, but the concept will extend to vectors, it will extend to circular buffers, whatever else I need. The main point of this experiment was to determine the life cycle of how a plugin is loaded into the host, how a plugin is started, and how we can use global variables to communicate between instances. And luckily, my experiment proved my intuition. When a plugin is loaded into the host, it is loaded just once, at least in Reaper. I haven't tested in other DAWs, but I think it makes sense for all DAWs and all hosts and all plugin formats to follow this concept. When you're loading into your host, your plugin will be running some parts of the code. For instance, it will be running this function over here that is responsible for creating a new instance of the plugin, a new instance of this object. But the cool thing is that this namespace that we are in, I guess not namespace, but this space that we are in is shared between all your plugin instances. So here is the trick. I have a global variable here, and that variable is global because it's not a parameter to a function. It is not a local variable in a function body. It is not a member variable of an object. It is, I guess, a static member of a class member. But I guess in this case it's not. It's just literally a global variable. And what I do, in this case, I'm using the user interface because I wanted to be able to see the effect of this global counter being incremented. So what I did is anytime that you load the user interface of the plugin, it will run this function for me. And this function used to just set the size of the window, but now it also increases the global counter, increments the global counter. And then instead of showing hello world as in the boilerplate that we saw a moment ago in Fotis machine, I'm just converting this into a string and showing the global counter. So this is what it looks like in the host. I can load I have like 35 versions of the Automixer here on my machine, but this is the VSC3 version. And then the counter is 1. And then I can have another track. I duplicate the effect. And now the counter is 2. So the counters are seeing one another. And if I close this window and reopen, then the counter is 3. That, to me, proves that the life cycle is when a plugin is loaded the first time, it will create this variable, and that code will never run again. And crucially, this variable is available to all instances. So they are different objects, they are different instances of the plugin processor and plugin editor, but they live in the same process. So I don't need any sort of fancy inter-process communication. The plugin instances can communicate via this global space. And I think that this amounts to the same as the gmem that I'm currently using in JS Effects. So I think that this will hold water. If I can make it in JS Effects, I will be able to make it here in C++. So the update that I have in the C++ land is very short. It's just 2, or I guess 3. 1, 2, and 3 lines of code, but the concept behind these 3 lines of code took me some time to think about and make sense of. How much does this make sense to you all?
Probably you will have to some kind of synchronize some variables, because if it will happen in the real time, then data will but could be updated asynchronously. Yeah. And this will cause some kind of problems for you.
Fair enough, yeah. So that's an issue in JS Effects as well, and I have to think about what we are going to do. We can use some primitives that are mutually exclusive and mute access, and we can use primitives that will synchronize access to stuff, but these primitives tend to be not safe for real time. So I don't know what we are going to do there. It will probably be a problem that will come up in JS Effects as well, and I do have some ideas of how I'm going to deal with this, but the issue, yeah, it is an issue, because suppose that suppose that I was able to open 2 instances of the user interface simultaneously, which is, I guess, doable if you have keyboard shortcuts and custom actions in Reaper. You could open 2 plugins sort of at once, and then this amounts to, this is actually another way of writing this, and then the 2 instances could both read a global counter of 0, then both instances would come up with a global counter of 1, and then that's a race condition. That's what I would need to think about and avoid. But I think that there are ways to get around this in the context of the plugin, where the most important thing that I will be sharing between the instances is their RMS. And if the RMS is off by 1 block, and also it's an important thing that it is a single writer, multiple reader situation. So that's already something that helps a lot. There is only 1 plugin instance that is writing to each slot in memory. But there are other issues that I will run into here with allocation and everything. So I'll have to think hard about how this is going to pan out. But at least it stands a chance of working.
There is some primitives in C++ like Automix. I'm not sure if they are thread safe, but it could work. You can try it.
Yeah, I
then
guess
please.
the whole point of Atomic is that it will be synchronized, so it will be thread safe. Well, I'll get to that when I get to that, but this is just a very simple experiment to make sense of the life cycle of how a plugin is loaded into the host and then how it is instantiated. And even if you close all instances, it's still in memory. So when I reload, now it's the number 4, not the number 1. So that helped me understand the life cycle of a plugin better. And that's the C++ part of the update.
Maybe it's somehow related to the Reaper lifecycle, those global memories.
Yeah, absolutely. If I close Reaper and reopen, then that will be back to 1. Yeah, in fact, that has happened, right? I opened Reaper for the stream, but of course I tested this before, so it was not the first time I'm doing this test. And if I close Reaper and reopen, then we'll get 1 again. And that's okay, because it just means that the Automixer is silent when you load the project, and then the Automixer instances will be writing RMSs into the global namespace here and there, and all will be good. As long as I allocate enough space, as long as I have everything starting with zeros to begin with, a mistake that I have made before. I was using whatever garbage was in memory instead of zeroing things out. Anyway, as long as I take care of these edge cases, it should be good. Right. Okay. So that's the C++ part of the update. Do you want to move on to the analog stuff?
Yeah, let's go.
All right. So for the analog stuff, what I want to share is this tool that I found that is called the Room EQ Analyzer. No, it's the Room EQ Wizard. That's the name of the thing. Room EQ Wizard. And it is often called REW. This is a piece of... Do you know about this software? Do you all know about this?
I've heard about the concept of
Yes.
room EQing with a microphone, right?
Yeah, so I think that originally this piece of software was designed to do that kind of thing where you have a measurement microphone and you have speakers and you are perhaps setting up a room for mixing or something. And then you use this software to calibrate, for instance, an EQ curve that may fix issues in your room, or maybe you just want to measure things to see how the room sounds. It turns out that it is a perfectly fine piece of software to do measurements of analog and electronics as well. Because...
Wait, are you using a Windows 11 virtual machine or is it a different computer?
I switched to a different computer.
Oh, okay.
Yeah. I don't think you can run a virtual machine in the M1 processors.
Oh,
I don't know.
I didn't know.
Yeah, it is. Yeah, I haven't tried. I prefer to steer away from virtualizing stuff because it is always slow and a bit of
Yeah.
a pain. So anyway, what this can do for people who are working with electronics is, well, it has all the usual suspects. You can do signal generation. For instance, here I'm generating a sine wave, and you can do other kinds of waveforms, your noises, and even your sine sweeps. You can do all of that. Then you can also do, of course, an oscilloscope. And previously I was using Reaper for all of this, and Reaper is okay for most of this, at least for generating audio and looking at an oscilloscope. The Reaper oscilloscope is good enough, but this goes way beyond that, and that's what I want to show. So remember how last time I did a simple filter and then I passed some white noise through the filter and then we saw a curve? That was fun, but it was kind of noisy, right, by the nature of the experiment. So what I would like to do is to do a sine sweep and plot the diagram. And perhaps there are plugins that do this. Perhaps there are even JS Effect plugins that do this. I remember playing with some of them. The usability was kind of weird, but they did mostly the same thing. For the basics, right? When you get into the weeds, this software is super deep. The Room EQ wizard is super deep. I guess much deeper than anything you would find in JS Effects, and in some ways even deeper than things like Plugin Doctor. But anyway, let me show you some of the things that stood out to me. The first is that the audio interface that I'm using itself introduces some artifacts. For one thing, remember I said that it was kind of filtering DC? There was some sort of high-pass filter. And what I learned is that, yes, it actually has a high-pass filter, and that's intentional. Almost all audio interfaces have this sort of high-pass filter. And it seems like Fotis is out of the call. So yeah. I'm removing his camera. I don't know what happened. Fotis.
I was disconnected.
Okay.
Also, almost all audio interfaces has low-pass filter on the output.
Oh yeah, the low-pass filter I knew about because you have to cut out frequencies so that the thing is band limited and you avoid aliasing. But what I didn't know is that it also has a high-pass filter. Most audio interfaces have, and most manufacturers don't tell you if it has a high-pass filter or not, but most do. And then, okay, so what is really cool about this piece of software is that you can set everything up, and I will not go into the details here because it's pretty much self-explanatory, and there are other videos going over how to do all this. But what's really cool is that you can calibrate your sound card. And what that means is it will do... Perhaps let's do this real quick because it's relatively straightforward to do. So let's go into Calibrate Sound Card, and I do have here my setup where this on the top is the audio interface. Is it? Yes. This is the audio interface, that cheap $20 audio interface I bought. And this is the output from the computer. This is a headphone jack. They just broke apart. And of course, these are all the negatives, and these are the tips that's carrying the left channel because my audio interface is mono. So we have that, and that's a bypass, right? These two channels are just connected straight, no components between them. So I can come here and let's see if this will work. I think it will. Okay,
not
so
bypass, but loopback.
Yeah, it will do a loopback kind of thing. And I do have to calibrate here the volume. So it will do a sine sweep going, right? And it will do that at minus 12 dB. And here I think I will have to decrease these numbers because I want what it's doing now, and the help here is great, by the way. It's just playing a 1K tone so they can calibrate the loudness. And I think that my audio interface is doing some kind of weird mono to stereo trick because it does add 3 dB of gain. So that seems like a pan law kind of thing. I don't know what's happening there. We saw that in Reaper last time as well. And I can just say to Room EQ Analyzer, just forget about it. It's good enough, right? Now, the output from my headphones and the inputs on my cheap audio interface are almost at the same level. And then it can now be measured. So let's play a sine sweep. So that's what it's doing now. And you can sort of already see the high-pass filter here and the low-pass filter there. But now that it finished, this is the best part. I really like this part. The graphs are great. We'll look at them in a moment. But before we do that, the other nice thing of this software as opposed to everything else that I saw is that now that I have this, I have an EQ curve of my audio interface. And this audio interface is not great because the anti-aliasing filter is cutting right through the audible range. And there is also this 2K noise going on with all its harmonics. It's some kind of interference. We saw that last time as well, and I don't know what that is about. But I can load this calibration file, that's what it's called, a calibration file, that is the measurement we just took. And now for every other measurement we do, so if I have a filter here on the breadboard, it will take this in account and it will compute just the difference. So it will subtract this EQ curve from whatever we measure, and we'll get EQ curves for just the thing that we are measuring. So like the filter, for instance.
Oh.
Of course, there is only so much it can do, right? Because we are losing information over here. It's a cheap audio interface, so whatever. And if I was using my proper audio interface, I probably would have something much better than this. But hey, here is the high-pass filter. And here is the low-pass filter, the anti-aliasing filter. It is crap, but there it is. All right, so I think
interesting. So in general, you can get more reliable data if you're doing some electronics.
Yeah. What I'm
the
finding
breadboard.
is that people who do electronics tend to need oscilloscopes, and we talked about this last time, how I don't have one. And if you have a very fancy oscilloscope worth like $300 to $400 to begin with, an entry-level oscilloscope, it will do some of the things that we are looking at here. But if you are just working with audio, you don't need a fancy oscilloscope because you're not going to too high of frequencies anyway. You are working with 20K hertz. You're not going over megahertz, for instance. And then you can use this, which is free, and you can use your audio interface and you can use your headphones and everything, and you can do a lot without having to spend too much. Now, of course, you don't want to probe any kind of the system using your audio interface because it is not designed to work over like 12 volts. You're going to fry the thing. So there is this simple circuit I found online that is essentially a gain knob. So you can lower the volume paired with a pair of clipping diodes that we also saw last time. It's just a way of hard clipping a waveform, or I guess clipping, I'm going to say, not necessarily hard clipping, but it's a way of clipping the waveform so that you protect the audio interface from overloads. And I still recommend that if you want to go and do this, probably you want to buy a cheap audio interface and buy perhaps even like I did, a cheap computer that you could fry if you wanted and no one is going to complain. But anyway.
The guinea pig.
Yeah, you can get by doing audio things. You can get by using just your audio interface, right? It's not perfect, but it's pretty good. And this software does things that some oscilloscopes, the entry-level oscilloscopes, will not do. So this is just a very basic plot, right? But it goes so deep. You can do like measurements of rooms, right? So you would need to see a waterfall diagram of the frequency response over time and that kind of thing. And
so I think that a company that recently made all of its plugins free, I think that their name was Blue Lab, and they had a sort of 3D oscilloscope, just like the one you showed, like a waterfall diagram. And I think that they released the code to that on GitHub.
Oh, nice. I didn't know that it was open source. I knew about the release of the plugins for free. I didn't know that they also released the source code.
I'm going to post it on the end of chat. And I was going to post one other program, Sonic Visualizer, but then I realized that it doesn't work in real time. It doesn't really work on audio files, as far as I could tell.
Yeah.
So you don't need it. But yeah, I'm gonna find.
Yeah, this is super convenient because everything is integrated: the generator, the scope, and everything.
Yeah,
and
I really like it. I'm gonna use it.
Yeah, the unfortunate thing is that I keep getting these null pointer exceptions, and the program is not open source. It is free, but it's not open source. So we don't have a way of fixing mistakes when they happen. So for now, let's just reopen. And perhaps it would continue to work, but when you get these kinds of errors, I think it's sane to reload stuff. Okay, so that was the calibration thing, which I think is super cool, and the generator and scope, which replaces what we were doing with Reaper before. But there is one more thing that I want to show coming back here. So there are all these calculators for stuff, and last time we saw an RC filter, a low-pass filter and a high-pass filter. And we were just playing with a trim, so playing with a potentiometer, and we were just a trimmer, not a trim. We were playing with a trimmer, and we didn't get precise values for cutoff frequencies or anything. But there are all these calculators you can find online for designing filters, for many other things when it comes to digital signal processing, and I guess in this case to analog signal processing as well. So there are all these calculators. So I guess in general, my advice is if you are thinking about designing something like a filter, try to find one of these calculators online, or even for something as simple as a voltage divider, like a volume knob, like we saw last time, there are calculators online for you to calculate the resistors that you need if you want to get precise voltages. Anyway, in this case, let's do... let's say that we want to have a center frequency of something like 5K, and I only have a couple capacitors here with me. I am going to buy a bunch of them, like different values, so that I can have more stuff to play with. But for now, I think that I will go with this 0.01 nano. No, it is 10 nanofarad. Or maybe I'll use the other one. Yeah, I guess I'll use the other one because it's a bigger value. Yeah, this 47 nanofarad. And then this is supposed to calculate the resistor that I need. And yeah, that seems like a good resistor value. So how about we put this to the test? So let's go to this camera. Here is our 47 nanofarad capacitor. Let me get this out of the box. And do I have a 680 ohm? Maybe not, and I will have to find the closest value. Oh no, this is the input. This is the audio coming in.
Probably your camera is lagging.
Oh, yeah, okay.
Because
my phone got hot probably, and my camera is stalling. But we'll get back. See?
Yeah,
it's back.
Better.
Let's try to find a good resistor for this. It says 680. I have 470 and I have 1K. I guess I will use 470. Okay, these are our guys. And a filter is a resistor. So this green wire is the input. Can I move it like this? Yes. So this is the input. And I guess what we are doing is sort of the same exercise as last time, but this time we are measuring stuff and we are predicting what the cutoff frequency should be, and we'll be measuring if the cutoff frequency really ends up being that. All right, so a filter is first off a resistor and then a capacitor, like so. And we want to tap in the middle of these two, so I'll tap in this same column and this is my output, or I guess this is my audio interface that is going to read the signal. But I need to connect all of this to ground. And I had a wire here on my desk. Does it happen to you that you have something on your desk, and then when you want to find it, it's no longer on your desk?
In the past, yes.
It is nowhere to be found.
Especially some smaller things like resistors or capacitors or SMD.
Anyway, here is another cable. It's not the best cable because it's red, but this is going to ground. The other leg of the capacitor going into ground. And oh, my pin is disconnecting. Getting there, guy. Okay, you got in there. That's our filter. Resistor, capacitor. The capacitor is going to ground, and we are tapping in the middle of the resistor and the capacitor. Great. But of course, we changed the value of our resistor. So let's get back to the calculator and calculate what the real cutoff frequency of this should be. So we are going with 470, if I remember correctly, and we are going with 47 nanofarad. Okay, so I wanted 5,000. We'll probably get 7,200. That's okay with the components that I have.
Okay.
Let's measure and see if this is actually what we get. So we can do a measurement, and it's going to complain about something here, and this is something to be aware of. As far as I understand, of course, this software is made to work with microphones and speakers. So it wants you to calibrate the SPL, the sound pressure level, or the loudness of the speakers in the room. But we are working with electronics here, so that is not a measurement that makes a lot of sense. So just continue without calibrating SPL. But another thing that is kind of cool, and I went over this when I was setting things up, is you can calibrate the voltage. So you take a multimeter and you put it in the circuit, and then you can see what, for instance, minus 12 dB. I guess this is the check levels button over here. Minus 12 dB in my computer corresponds to 60 millivolts on the breadboard. And then I can put that value, and then I can say, okay, now give me not minus 12 dB, give me, I don't know, 60 millivolts. And when you're doing measurements on the breadboard, this is so useful. I don't know of any other software that does this translation for you. And it's a simple multiplication, but it's a quality of life thing that I really like. Anyway, let's start the measurement. I think I have something that is misconnected because I just seen a bunch of zeros. Let's cancel this. And I will give this just one try because I want to show these features as well. And we'll try to see if there's something wrong here with my breadboard. And if that doesn't work, then it will... I may have another measurement that I can load. But anyway, so here we are doing a sine wave of 1,000 hertz at minus 12. Let's play. And on this side, the record button is not really for recording, it's just for showing the waveform. So it seems like we are measuring silence here. Maybe my cable is not connected right? Yeah, that's what was happening. So my cable that I was having trouble putting in the breadboard, it wasn't really connected very well. Anyway, it was a good way of showing this. And of course, this is in real time. And of course, you can zoom into the waveform. There are all your usual controls for an oscilloscope. So the number of volts per division, the time, you can have different triggers. pretty standard for an oscilloscope. And of course, this is in real time. So if I change from minus 12 dB
Nice.
to minus 6 dB, the waveform gets taller, as you would expect. Let's try the measurement again. And this time we are getting some signal. And there it is.
And we have different one in comparison of with previous one.
Yeah, so this is our low pass, and the cutoff frequency is, we expected it to be at around 4,200, and, or sorry, 7,200. That's what we expected, 7,200. And here it is. It doesn't seem exactly right, because the difference between this, the passband, and 7,200 is supposed to be 3 dB, right? Well, this is in SPL. That's not going to help.
Something.
So let's change the unit of measurement here from that to dBFS. So the passband is at minus 6 and 7,200. Yeah, that went from minus 6 to minus 16, which is a minus 10 dB. So perhaps the cutoff frequency here isn't great. That may be because my resistors and capacitors are not exactly their nominal value. I haven't measured them with a multimeter. But anyway, or maybe I'm doing something else that is completely wrong. And if that's the case, then please let me know in the chat. But I thought it was interesting to show this because it is a much cleaner plot than what we had in Reaper, and it's much more principled, and it got rid of all the artifacts from the audio interface. So over here there is no longer a high pass filter because it compensated for that. It's just showing the low pass filter that we developed here on the breadboard.
Well done.
Thanks.
Cool. This looks like you can make some electronics and make some different audio measurements on that electronic without big problems.
Yeah.
And without any specific equipment.
Yeah, so my plan for next time on the Automixer land, I cannot promise much because I'm working on the JS Effects version, and I will deal with all the intricacies of synchronizing and race conditions and whatnot in JS Effects. And if you all are interested in this, then keep watching my streams on the other days of the week. But I'm not going to promise much on the C++ part of things. But here on this electronic stuff, my plan is to build this circuit I found online that allows me to measure anything, even with high voltages, that allows me to measure anything using just my sound card, using just this little cheap device that I got.
Nice.
And that
Like a
and to
voltage
protect
divider?
everything. What was that, Cwits?
Like a voltage divider, or
Yeah, it is a voltage divider, but it's also some clipping diodes, and I think that's it. I forget. Perhaps there are other parts to the circuit, but anyway, my plan is to have this device so that I can measure different parts of that. Remember that guitar pedal, the overdrive pedal that I showed last time? I want to be able to probe into different parts of the thing to see what's going on. For instance, I want to see the ripple in the power rail, if there is any. I want to be able to see that kind of thing, and maybe it's too high of a frequency. The ripple would be too high of a frequency for me to see, but I want to see all of that, and for that I want to have this little device. I'm going to build that, and I'm going to probe and learn more about the system that way. And who knows, I may even get to doing the usual suspects. Like, I would be interested in doing the Atari Punk console. I would be interested in doing a 555 oscillator, and even the the fuzz for a fiver kind of circuit, which is much simpler than the overdrive I already did, but it sounds like fun to do all these things.
Yeah, it is quite fun, but there is some kind of problem that it took a lot of time, and it also took a lot of time to kind of debug things, because I had couple problems earlier that I have made some circuit and it not working, and you're trying to find like with the same like with code. You made something, it's not working, and you waste a lot of time to find out the problem source.
Yeah, but I guess it tickles the same part of the brain as writing code. When you eventually find the solution, it is very rewarding.
Yeah.
Oh yeah, I was going to say the end of my story about the S-video cable. So I was, after all my experiments, there was an S-video cable that I was trying to plug into another one, the male into the female, and it wouldn't fit for some reason. So I looked into the cable, and I noticed that one of the 6 pins was bent because I used it too much. So what I did was I took a sewing needle and I pushed the pin until it was straight again, and so it worked.
Right.
So nice. Yeah, it was analog debugging.
Nice.
Yeah, but it taught me that there is a solution for everything.
Right. Okay. So there are some things here on the chat that I want to talk about. Tail is talking about first the timing thing, and Cwits is discussing. So if other people are interested in knowing more about this timing situation and even some solutions used by old school gear, then make sure to check the live chat replay somewhere here on the interface of YouTube. But Tail is also saying that I think that all analog inputs will include a high-pass filter to block DC. This is probably to protect the components down the line that might not like high DC offsets. Oh, that's fascinating. I knew that it was doing some kind of high-pass filter. I didn't know why. I thought it was because when you're working with audio, you don't care about DC. You just care about the AC component. But yeah, you are right. You could be frying things if you don't filter DC.
Yeah, don't do it. Please, people, don't. You can blow up your speakers. This is not a joke with DC offsets.
True.
Basically, a lot of audio interfaces have like something like phantom power for microphones.
Oh yeah.
And this phantom power is going after high-pass filter.
Oh.
So
yeah, it needs to be, otherwise the phantom power would be filtered out, right?
Yeah.
I didn't know that.
It has to be filtered out because we don't want like DC component on our sound card.
Yeah.
In our sound.
Yeah, and Dale is also saying your audio interface will have a frequency range in its spec. Right, that's right.
Yeah.
And if it is saying that it's from 20 hertz to 20 kilohertz, then there must be a high-pass filter below 20 hertz.
Yeah.
True enough. That makes sense. I never thought about it that way. I always thought of the anti-aliasing filter at 20K, but I never thought of the high-pass filter, the DC blocker at 20 hertz. And that's true, or below 20 hertz. That's true. And then there is a question. Audio dB is 10 to the power of x over 20, and other dB is 10 to the power of x over 10. Maybe, I don't know. Where did you see other dB? It was probably somewhere in here in the room EQ wizard thing, but I don't remember seeing that, so I don't know the answer to that. But it could be, because you could be talking about dB of power scales, and then you would be dividing by 10 instead of linear scales like voltage, and in voltage you divide by 20.
By the way, my brother has an Audio-Technica microphone that uses phantom power, and it has a built-in high-pass filter that you can turn on and off with a button on the microphone itself. It even has the filter shape like the one we see in the equalizers drawn on the microphones. So that was a nice thing. And also that the Room EQ wizard reminded me of audio-visual amplifiers for home theater systems. Some of these come with a microphone, and they have their own Room EQ wizard-like software built inside the amplifier, so you can control the software with your remote control on the TV, and then you can use the microphone to calibrate all of your surround home speakers, so you can tune each one of them to your own room.
Nice.
And also SonarWorks is making their own microphone for room tuning.
SonarWorks is great, as I heard.
Yeah. I'm using Equalizer APL.
I tried it.
I know.
I'm not in love. Doesn't make a huge difference, I don't think. Anyway, and Tail is saying if -6 dB is the cutoff point, then other dB, I guess, because in audio the cutoff point is -3. True enough, but even then, I got a difference of like 10 dB at the cutoff frequency that I was expecting from the calculator online. So I don't know. And it's kind of cheap for me to use a calculator online because it's just 1/2 pi RC. But anyway, I used an online calculator. And Cwits is asking if dBFS is something different than just dB. And the answer is very interesting, actually. dB is just like kilo or milli in the sense that it's not a multiplier, but dB is just a way of communicating some measurement. And then the thing that comes after dB is what the dB is in relation to. So when we say dBFS, as we typically say in the digital domain, it means dB with respect to the maximum value you can represent. And that's what's called the full scale.
The full scale, yeah.
But then in the analog domain, there is also dBV, and that's when you're talking about voltage. There is dBu. There is lots of dBs. There are lots of dBs. There are many that I don't even know what they are. dBW, dBr. I don't know what those are. But anyway, it's interesting to learn about these other units of measurement.
Yeah, and full scale is also applied to LUFS, loudness unit, full scale, which is a different method of measuring audio volume. But yeah, the full scale principle applies there.
Yeah, and Dale is saying that most people in audio use dB as 10 to the power of x divided by 20, but the rest of the world, including electrical engineering, uses 10 to the power of x divided by 10. And that is a difference in the nature of the thing you're measuring. So if the thing you're measuring is linear, like voltage, and you want to compute the dB, something like dB full scale, if you are transferring into the digital domain, then that's something that you need to divide by 20. But there are contexts in which you are doing something that is not linear. It's already in the, I guess it's a power domain then. It's already in the power domain, so you would be dividing by 10 in the exponent to compute dB. There is a Wikipedia article that explains this in more detail. I forget what it is, though. I guess it's the decibel Wikipedia article. Yes, it is. So people interested in knowing more about this can read or try to read the Wikipedia article for decibel, and they will learn about linear and root power field quantities and power quantities. Gets complicated real quick, but anyway, it's interesting.
Is that why you named the stream It's Complicated?
Yes, because Cwits was saying that he was struggling to find things to talk about, and I am working on complicated issues with the Automixer, so that's why I named it. It's complicated. All right, so...
And you asked me, why don't you have a Reaper license? It's complicated.
Yeah. All right, so let's wrap this up. We already said what we want to do for next time, so do you have any final words?
Oh, yeah, I'm thinking my mind is blank right now, but one thing I wanted to say that
Probably he.
The one thing that I wanted to say, and then the connection drops. Cwits, final words?
Good luck to us, to everyone in trying to find solutions to our problems.
Yeah. All right, and also my computer is falling apart here. It seems like the stream is lagging even because it's not receiving enough. That's what YouTube says. It's not receiving enough video to maintain smooth streaming. So it is really time to wrap this up. So Fotis, whatever you had to say, you can say it next time. Thank you, Fotis and Cwits, for joining me here on this meeting. Thank you to Bo and Tail, and there was also another comment by someone else, but it was removed. So thank you everyone who's on the chat, and thank you everyone who's not on the chat but is watching this in the future. And yeah, I see you again tomorrow or Friday. I may take tomorrow off, so subscribe to the channel and you see. But next time, either tomorrow or Friday or Monday, who knows.
Sorry, I got this.
Oh, you're back. Okay, so next time I will be working on the Automixer, and I think I figured a solution for the problem we had last time. So you will not have to hit play to register all the Automixer instances. So look out for this next stream in which I will try to implement this other solution. So Cwits, final words, and then we'll end this stream.
I said already.
Oh, Fotis, sorry.
I hate my internet connection. The optical fiber can't come soon enough.
All right. So thank you, everyone. I see you next time.
Thank you. Bye.
Bye.
Goodbye.
Thank you for watching the stream. You know how great it has been. Or maybe it sucked, and I am glad that you stuck with me. And soon we'll all be back together for some more coding or talking or chilling. The next time I'll be streaming.